Hello children, welcome back. So let us now try to solve the exercise problem from kinematics. So moving to the first question, displacement is a. Children, we know that displacement have both the magnitude as well as direction. Hence, whenever a physical quantity which has both magnitude and direction, then it is a vector quantity. So displacement is a vector quantity. Therefore, the correct option is option 1, that is vector quantity. So moving to the next question. A player hits a baseball. A player hits a baseball at some angle. The ball goes high up in space. The player runs and catches the ball before it hits the ground. So he has to hit the ball. The ball goes up and again falls downward. So the player has hit the ball at this moment, and as and when the ball falls at some particular position, the player also displaces the same path. Okay, so which of the has greater displacement? So very clearly, if the ball moves up and comes down, this person after hitting the ball, again moves this particular displacement to catch that ball. That means very clearly, if the displacement of the ball is yes, then the displacement of the man must also be yes. That means both have, what is displacement, children? The line joining the initial position and the final position. So, ball moves here, comes here. Person moves from here, reaches here. So, the displacement of both ball as well as man remains same. So, what is the correct answer? Which of the two has greater displacement? Both have same displacement. Is it the player, the ball? Data insufficient, or both have the same displacement? The correct answer is both have the same displacement. So, option 4 is true. Moving to the next question, third one, a ball is thrown up with certain velocity. It attains a height of 40 meters and comes back to the thrower. So, what is given, children? Ball is there. This ball reaches certain height and again falls downwards to the same height. So, ball is thrown up with a certain velocity. It attains certain height. And what is the height given, children? The height given as 40 meters. And comes back to the thrower. Then the total distance covered is, what must be the total distance covered? So here, this ball has to move a distance 40 meters upwards, and again it comes down by moving 40 meters. So what is the total distance covered? The total distance covered must be 40 plus 40, that must be 80 meters. So this must be wrong. The distance covered must be 80 meters but not 40 meters. What is the magnitude of displacement? Magnitude of displacement, if you observe that the initial position of the ball is here and even the final position after going here and again coming back, even the final position of the ball is also same. So, the distance between the initial position and the final position is again 0. So, magnitude of the displacement is not 80 meters, it must be 0. So, this must be wrong. So, what is that? Displacement is 0. This is what we have discussed. So, yes. So, displacement is 0. Total distance covered is 0. No, what is the total distance covered? 80 meters. So, only one option is correct and that must be third option. So, how much is the displacement, children? Same initial and final positions, hence displacement is 0. Moving ahead with the next question, fourth one, assertion. The numerical ratio of the displacement to the distance is equal to 1 or less than 1. So, children, as we know that displacement can be negative, 0 or positive, but the distance is always positive. That means distance can be greater than or equals to displacement. So, magnitude of displacement is either less than or equals to the magnitude of distance. So this, you already know this, magnitude of displacement either less than or equals to displacement, because distance always takes a positive values, whereas displacement can be negative, positive or 0. So now what they're asking us to find out is the ratio between the displacement to the distance. So bring this distance here. Then what happens? Displacement to that of distance must be less than or equals to 1. The numerical ratio of the displacement to the distance is equal to 1 or less than 1. So, the first statement is true. Moving ahead with the next one, reasoning. Displacement is a vector quantity and distance is a scalar quantity. Is it true, children? Of course, displacement have both magnitude as well as direction. So, no doubt it is a vector quantity, whereas distance, it is having only magnitude. So, it is not dependent on nothing to do with the direction. The path length covered by a body is called as distance, but displacement has a specific direction. Okay. The distance covered by a body in a specific direction is called as displacement. So, clearly displacement have direction, whereas distance doesn't have any. So, from this we can conclude that displacement is a vector quantity and distance is a scalar quantity. So, displacement is a vector quantity, distance is a scalar quantity. So, we can conclude that both the statements, that is assertion as well as reason, both are true. Since it is a vector quantity, it has a direction, we can conclude that displacement can either be. So, as we know that the magnitude of the displacement is either less than or equals to distance, because displacement can take either positive values, negative values or 0, because it is a vector quantity. So, reason is the correct explanation for assertion. Because of those factors, its ratio is less than or equals to 1. So, which one is the correct one? Both assertion and reason are true, and reason is the correct explanation for assertion. Where is that? True, and the reason is the correct explanation. So, no doubt the correct option is option 1. So, first option is true. Assertion and reason both are true, and reason is the correct explanation for the assertion. So, moving ahead with the next one, fifth question, statement 1. Displacement of a body may be 0. Of course, even when distance travelled is not 0. Is that possible, children? Of course. How? So, consider a one-dimensional axis on which let us plot some values 0, 1, 2, 3, 4, something like that, -1, -2, -3, so on. And let us consider that a body has displaced from origin, moved a distance, this is measured in kilometer. Okay, so meters, let us consider meters. So, everything measured in meters. This suppose that the body has travelled a distance of 3 meters and again moved back by covering the same path length. So, going here to here is 3 meters and again coming back is also 3 meters. So, what is the total distance? Total distance travelled by the body is equals to 6 meters. How much, children? Total distance travelled is equals to 3 plus 3. In our example, it is 3 plus 3, that is 6 meters. But what about displacement, children? The value of displacement is, here let me write it as 3 plus 3, and this is equals to 6 meters. But what about displacement? From here to here, in this direction, positive direction, we consider it as plus 3, and in the opposite direction, we consider it as minus 3, and here the answer is 0. So, in this example, we proved that distance is positive, is not 0, whereas displacement is 0. See, is that first statement true? Displacement of a body may be 0 even when the distance travelled is not 0. Yes. So, statement 1 is true. Moving to the statement 2. Displacement of a body cannot be 0 even when distance travelled by it is not 0. It's a contradictory statement because we proved that it can be 0. Then So no doubt this statement is false. So among the given two statements, we observe that only one statement is true, that is first one, and second one is not true. So where is the correct option, children? Statement 1 is true, whereas statement 2 is false. Hence, the correct answer must be option 2. So moving ahead with the next question, that is sixth one. Pick out the false statement from the following. So you are given 4 statements, children. So what is the displacement is a vector quantity and hence direction is important. Pick out the false statement. Displacement is a vector quantity. We have already discussed that displacement has both magnitude as well as direction. So it is a vector quantity. And hence direction is important because it has direction, specific direction, then only we can consider this as a vector quantity. So first one is true, but we are asked to find out the false statement. Moving to the second one, displacement can be both positive and negative. Of course, displacement can be positive values as well as negative values, or can be 0. Even the second statement is also true. Moving ahead with the third question, distance is always positive. Distance is always positive. Okay, that's true. It never decreases with time. Distance itself means the path length covered by the body. As and when the time is increased, the path length covered by the body also increases. So distance is always positive. It can never decreases with time. How can it be? Okay, so it only takes up positive values. Hence, third option is also true. Moving to the last one, distance can be negative. Is it possible? Never. So distance always takes positive values. It can never be negative. Hence, this must be a wrong statement. The only false statement from the following is fourth one. That is, distance can never be negative, but here it was given as it can be negative is a false statement. Moving ahead with the next one. Okay, so with this we have completed with exercise 1 of kinematics chapter.